today we start learning how to move our functions around graphically. And we're going to just start off here with the easy shifts, which will be the vertical and horizontal shifts. And you've heard me refer to these before over the last few weeks. Now we're going to officially learn how to do this. Okay. So let me just kind of give you some rules here. If I have rule number 1, if I have x to the b power plus c, that's going to be a shift up c units. All right. So, real quick, let me just do a quick example of this one, and we can just do this real small. Let's say that I had f of x equals x squared plus 3. All right, just the regular granddaddy quadratic function with no b term or c term, and it just says x squared plus 3. Well, that is going to be a parabola where the minimum value is moved up 3 units. All right, so we can just move the base parabola up 3 units. So what do you think it is, rule number 2, what do you think it is if it's x to the b minus c? Then we go down. And we'll just put down. All right, so if I had, real quick, for example, f of x equals x squared minus 5, then that's going to be the base parabola, and you take the minimum and move it down 5. So 1, 2, 3, 4, 5, and that parabola is going to look like that. So the minimum value, or the vertex of the parabola, which we will talk about later, gets moved down 5 units. Okay? So, those are the first 2 rules. The next rule is if, and by the way, let me kind of come back here for a second. These rules also apply to the square root function. Okay? I'm not going to draw all of these right now, but just keep in mind that these also apply, or also applies to other functions. It's not just the quadratics. Okay, we're going to do some more examples of that in a minute. All right. Third rule. What if I have x minus c in parentheses to the b power? Now this one is the opposite of what you would think it is. Okay, this is a horizontal shift. All right, this is a horizontal shift. C units to the right. Okay, I know that when you see that x minus c, you would think that it would go to the left, but it does not. So, for example, let's use a different function than the quadratics. Let's say that I had the square root of x minus 4, like that. Okay, and I wanted to know where that thing got moved. Well, it's just like my rule up here. So this thing is going to be, I'm going to take the parent function, which remember, the parent function of the square root function looks like that. That's what the granddaddy graph looks like. So we're going to take this point right here and we're going to move it right 4 units. So this graph would look like this. All right? And it would be the same thing if I had a quadratic in parentheses. We'll do some more examples of these in a minute. Let's get through our rules. So if I had x plus c to the b, remember what I told you, this one's kind of opposite. It's going to move left. Okay. Real quick, I'm trying to give you some examples as we go along so that you can have a visual image. What if I add x plus 2, the quantity cubed? Like I said, these apply to the, to all the functions we've worked with so far. Well, the regular cubic function, the granddaddy cubic function, kind of looks like that and goes through the origin. Well, this one is going to be moved to the left 2 units. So this point right here is going to go this way. And so now it's going to go through that x-intercept of -2. Move to the left 2 units. Okay? So these rules are true, for all of these common functions that have a power. All right? We're not going to apply them to linears, though, because linears have their own way of being moved around. All right? So let's just kind of do a couple quick examples. All right? Let's graph without the TI-84. Well, the idea here is this helps you get a mental image of your function family and then just move them accordingly. So, and let's kind of try to do these quick, all right? Let's say that I had the square root of x plus 2. Now notice the plus 2 is outside of the radical, all right? And by the way, you all need to start training your mind with this a little bit. If you go back to when I started this day, didn't I say x to the b power? Well, can I write the square root of x as a power? I sure can. Isn't this the same thing as x to the 1/2 power? Okay, you need to keep that in mind. Don't ever forget that the square root of x is x to the 1/2. That's not going to go away. That's a skill you've got to have. So this is like x to the 1/2 plus 2. So we said when I have that plus 2 outside of the power, that all I do is I move the base function up 2 units. So instead of being down here, it's going to start right here and go like that. All right? Let's do another one. How about f of x equals x plus 4 quantity squared? Which direction is that one going to go? To the left 4 units. This one's easy. It's just our regular quadratic. 1, 2, 3, 4. We move our vertex to the left 4 units, and it would be like that. Now, one thing that we have not, that we still need to talk about, and I'll remind me, and we'll make sure we need to talk about the absolute value function before the day is out, because we're going to run into those a little bit. What if I had f of x equals the square root of x minus 2? Well, this one is inside my radical, so that means it's a horizontal shift to the right 2 units. So it'd look like that. Okay? Now, we also need to talk about reflections. Reflections. And when we talk about reflections, we're talking about flipping it upside down or flipping it across a certain axis. All right? The easiest way that I know to do this is this way, rule number 1. If the negative is outside, then it gets flipped down. If the negative is outside, it gets flipped down. If the negative is inside, it gets flipped across. So we should probably need to, into your notes, make sure you have the word flip. Flip down, flip across. All right? And probably the best one to see this with, I believe, is the square root function. All right? So let's look at, this is where I'd like to use our graphing calculator for a minute. All right? Let's put in the regular square root function. So the square root key, by the way, second is right here above x squared. So the square root of x. And we'll just do zoom standard. And we know what the granddaddy function should look like. There's my square root function. Okay? Now, let's graph it with, let's go back to my y equals. And in my y2, let's put a negative in front of the square root of x. Don't put a minus sign. It'll be an error. Put a negative, and then square root of x. And let's see what happens. There it is. It's flipped down. All right. Now let's go back, and for our third function, let's make this the square root of negative x. And this one should be flipped across. Okay? Now, what if, we have actually one more we need to look at. What if there is a negative on the outside of this square root function and a negative on the inside? What happens then? It gets flipped twice. Okay? Gets flipped across and then gets flipped down. So we better put a sketch of this in our notes. I'll move it into my Memio document so that I can write on it. Okay, these are the reflections of f of x equals the square root of x. All right? So the first one right here, that's the square root of x. Okay? And then we said if you put a negative in front of it, it flips it down. So this is the negative square root of x. And then if you put a negative inside it, it gets flipped across. So this is the square root of negative x. And then if we put a negative outside and inside, it gets flipped twice. So that one would be here, the negative square root of negative x. All right? So, the easiest way to keep these straight is back to this rule right here. Outside, down. Inside, across. Okay? So that's the easiest way to keep those straight. What if, let's do this same little exercise now with a quadratic function. Okay, let's go back to our y equals and clear out all of this junk. Clear, 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 and clear. We don't want to plot. All right, so x squared. We know what that looks like. Okay, there's my regular quadratic. Okay. Now, what if I have just plain old negative x squared? We'll do that one down here. I think we all know what that one's going to be. Negative x squared is going to get flipped down. It's going to be upside down. All right. Now, where the quadratic gets a little bit, where we have to kind of pay attention a little bit more, is what if I have something like this? What if I have negative x squared plus 3? Now, here's one thing you can do to kind of help yourself think through this a little bit. What would happen if I put in 0 into this function? Well, what's 0 squared? 0, right? And so then I add 3, right? So you know this is going to be, that's going to be the vertex of your parabola. So this thing's going to be upside down, and the vertex is going to be moved up 3. Let's see if I'm right. Yes, I was. Okay? So, it's upside down, and it's moved up 3. Okay? Let's do another one. Just trying to give you some examples here for what you might see in homework, because we're going to have to be able to do this without a graphing calculator. What if I had negative x squared minus 6? Okay, well, now let's think through 0 again. If I put in 0 now, 0 squared is still 0, but then I have to subtract 6, right? So this thing is going to, the vertex is going to be down 6 units, and it's going to be upside down. So it's way down there. Okay? So let's put a little copy of this into your notes, because this is good reference material. Sometimes these have a tendency to get a little bit confusing. So this one right here, of course, is x squared. This upside, I'll try to color code these. I'll sketch over top of them. This red one, okay, red is negative x squared. The blue one and you can label them 1, 2, 3, whatever you want to do, but this is just how I'm doing it, is negative x squared plus 3. And then the Christmas green one, this one down here, is negative x squared minus 6. Okay, so however you want to label those in your notes, that's up to you. But we do want to keep all of those flips straight. Now, one other thing that we need to look at is the impact of a horizontal shift on quadratics. So let's leave the parent function in there and let's clear out the rest of these. Let's say that I had a negative and then x minus 2 in parentheses squared. Now, if you see this one, the negative is outside, so you're thinking it's flipped down, all right? And it's also been moved to the right 2 units. Let's see if that's correct. There's my parent function, and there is my transformed function. Okay, it's moved to the right and flipped down. Now, where you have to be a little bit more cautious is when we get a function like this one. Let's say that I have negative and then a parenthesis and then negative x minus 2. Okay, so let's see what happens with this function. I'm just going to graph it and let you see where it winds up. So do you see what happened? Didn't it get reflected across the y-axis? All right, because of that negative on the inside. Okay, so we still had a shift right, and then it got flipped across. Okay, so let's put these into our notes as well. Again, this really helps us keep things straight here. I think if we just see some of these examples. I didn't take a screenshot there. Better do that first. So again, labeling these, we know what the original one is. This is x squared. Okay. This one here is negative x minus 2, the quantity squared. And this one here is the negative of negative x minus 2 quantity squared. All right? Now, before I run out of time, I want to take a look at the absolute value function. And did we add this one to our function family? Okay, the absolute value function is a part of our function family. Okay, this is I guess we could say a new family member. All right, so if I have f of x equals the absolute value of x. Well, remember what absolute value says. It says that whatever you take the absolute value of, it's always positive. Well, what does f of x equal x look like? Isn't it this? Isn't that f of x equals x? Well, what happens with the absolute value function is this part right here. Aren't those all negative function values? Well, if I have absolute value, they can't be negative, so this gets reflected across like that. The absolute value function is the v. Okay? The parent graph of the absolute value function is this. And guess what? All those transformations that we just worked with still apply. All right? If I were to graph, what if I wanted to do f of x equals the absolute value of x minus 2? Well, that would be the v moved to the right 2 units. Boom, boom. Okay, all those transformations still apply to the absolute value function. All right? And that includes the vertical shifts and whatnot. Now, the last thing I want to do with my time is I'm going to say the crazy square root. And what do I mean by the crazy square root? Well, I'm going to show you on the graphing calculator. And this is one that I just think it's best seen on the graphing calculator. Because when you start, for some reason, the square root function, when we start adding several transformations, can get a little bit confusing. So let's say, we've already talked about the base transformations, flipping it down, flipping it across, but what if you combine a couple like this one? F of x equals the negative square root of negative x plus 5. Okay? Now, you kind of have to think through this a little bit. You know, that plus 5 makes us think that it's going to go to the left 5, right? And don't we have two reflections here? So let's see how it turns out. And this is why I call it the crazy square root function, okay? Because that plus 5 makes you think it needs to go to the left, right? But you have to remember there's two reflections in here. So that's why it winds up looking this way. I'm going to write on this thing. This graph right here, this function that we graphed was f of x equals the negative square root of negative x plus 5. Okay? And, you know, to me, there's no real sensible way to think through the reflection order on this thing. Obviously, it's been flipped twice. It's went from here to here, right, to then being down here, right? The best way for me to think of it is to think through those reflections and then just think, oh, isn't this the same thing as the negative of x minus 5? Aren't these two the same thing? Right? And so what you've got is you've got two reflections, and then you've got this vertex point moved to the right 5 units. Okay? So again, let's do one more real quick before the bell rings. Let's do one more crazy one. How about this one? The negative square root of negative x minus 4. Okay, let's see where this one winds up. So do you see what I was talking about taking out that negative? All right. So if I graph, I'll just go back to Memeo now. This would be the first one. The second one, f of x equals the negative square root of negative x minus 4, winds up being 1, 2, 3, 4, and it winds up being here. Probably the best way, I think, to do these is to almost think a little bit backwards, right? Because look, didn't we flip this one twice and then go right 5, right? And then this one we flipped twice and then went left 4, right? So with those, it's probably better to think a little bit backwards, and we will stop there for today.